Assalamualaikum warahmatullahi wabarakatuh. My name is Shasa binti Aziz. My ID matric is 2020788479 and I am from class M3CS2306A. Today, I am going to present my final year project presentation titled Social Distancing Detection System using Deep Learning. But before that, let me introduce and greet my supervisor, Sir Muhammad Taufik bin Mishan, my lecturer CSP 650, Dr. Siti Faris binti Ahmad Faisal, and my examiner, TS Dr. Shafaf binti Ibrahim. Introduction. During the COVID-19 pandemic, governments tried a variety of social distancing measures, including restricting travel, controlling borders, closing pubs and bars, and warning the public to keep 1.6 to 2 meters apart. However, keeping track of how far an illness has traveled is a difficult process. People must go out for basic necessities such as food, medical treatment, and other important courses and jobs. The purpose of this system is as precaution action to prevent the expansion of the disease by minimizing the closeness of human physical contact in covered or crowded public places to stop the widespread accumulation of the infection risks of COVID-19 and monitor people distance between each other using computer vision. Secondly, problem statement. For the first problem statement, some people do not want to social distancing and need to be keep monitoring so that it would not harm anyone else. Many problems need to face by people before this system exists, especially for an owner of premises and for police. Also, since they need to monitor people at food court, entertainment events and shopping mall. And the second problem statement is there's less existing system in social distancing detector. Mostly the researcher only making a prediction model and mostly do not develop it to be used in real time. Next is project objective. Here, my system has 3 project objectives, which is firstly is to design a social distancing detection system that able to remain social distancing between people, and second is to develop a social distancing detection system using YOLO model, and the third objective is to test the functionality of the system. And then project scopes. The goal of this project is to assist individuals maintain social distance from others even in crowded situations in order to diminish positive COVID-19 incidents. As a result, this system has been used deep learning approach to transform CCTV cameras or ordinary camera in the prison infrastructure capacity into smart cameras that not only watch individuals but also control whether or not they adhere to social distance rule. Then, next is project significance. Essentially, the relevance of this project is that it can identify people's social distance in real-time monitoring, which may aid in the decrease of COVID-19 infection. It may also minimize workload for other individuals such as event organizer or premise owner who has to be advise people to not be too near to one another and can be protected from compound. Methodology. The methodology that I use in my final year project is waterfall model, which waterfall model has 5 phases, which is the first phase is planning, the second phase is analysis, the third phase is design and development, the fourth phase is testing, and the fifth phase is documentation. Next is my flowchart of my system. Firstly, we start the system, and the system will input image or video, and the system will use object detection model, which in my system I use YOLO model. YOLO model has pre-trained as COCO dataset. So the system will determine bounding box and calculate centroid of detected bounding box, and then they will initialize the color of the bounding box, which is green. And next, they calculate Euclidean distance between each detected bounding box to define distance threshold. If people at distance which is more than 85 pixels, if yes, that means they are maintaining social distancing and it will display green bounding box. And if the people is at distance which is less than 85 pixels, the social distancing violation is detected and the bounding box will update the color and display to red bounding box. And The lastly is both of them with total number of people who maintain social distancing and also with total number of people who violate social distancing in order of serious violation or abnormal violation. For abnormal violation, they are in bounding box uh, bounding box yellow, which is not as serious as red bounding box. And then after that, the system will end if the user end the system. This is my use case diagram, which is my system only have three actors, which is the first one is user, the second one is camera, and the third one is system. For the camera, they input image or audio, and then for the system, they detect person and they extract features and they determine whether the person is followed social distancing or not. And for the user, they only open and close the system. Finally, we have reached the end of my final year project presentation where I will demonstrate my system. Firstly, my system is run by localhost by XAMPP. So the first thing we need to do is to start XAMPP control panel. And then we type at the Google browser localhost and my folder social distancing, and my interface is index.php. So I run my interface in browser. And here is my interface, which has social distancing detection and open button camera. To start the system, user can click the open button camera. And here is video that I use for demonstration system testing, which is there we have human count, threshold limit, safe distance, total stress variation, and total abnormal variation. Total stress variation is the one who in red bounding box, and abnormal variation is for who the one in yellow bounding box. The system also count human in the camera as the input. As you can see, here the result. Safe distance is same like the social distancing measure, which is 1.6 meters to 2 meters apart. And here the first image that I use, as we can see here the result. And this is the second image that I use for the demonstration setting. And this demonstration proved that my system is fully functioning. That's all from me. Thank you.